of differential equations. So this application that I'm doing today, it's about a tank. Let's put a tank, like any kind of tank for the moment. For the moment, we won't put a specific geometry, but I'm just gonna put like a cylindrical one. And this is a tank that's gonna have like fluid, let's say water for the moment. And the tank is gonna be constantly losing water because there is a little opening here, so the water is gonna come out. So we want to see how the tank is gonna empty, is emptying. And we would like to see how the actually like the height of the fluid in the tank is gonna vary with time. Okay, so well, let's call better h to the height, and let me call y a different variable. Okay, so basically we start with a tank that has 400 liters. Okay, and it has water. Let's say it can be applied to any kind of other fluid. And what we're gonna do, it's put in some salty solution, added to the water in the tank. So I'm gonna add the salty solution which actually contains 1/8 of kilogram of water, of salt, sorry, per liter of water. So basically the salty solution is salt plus water. And we say that the concentration of the salt, it's 1/8 of 1 kilogram, okay, of salt per unit, per liter of water. So we're gonna be adding this salty solution, this following frequency. So we add the salty solution at the rate, and this rate is gonna be 8 liters per minute. And we are gonna suppose that the whole mix is gonna be homogeneous at all the time. So the mix of salty solution, which is basically salt plus water, plus the mix with the water in the tank, it's going to be homogeneous. At all times. So basically it's uniform, so we don't have to focus on anything local. Okay, so this is the problem. So now it tells us that the actually, like, we're filling up, we're adding 8 liters per minute of the salty solution, but we said that we have a little opening here. Actually, this little opening, we're supposed to have that it has a cross section of area A. Let's call it A. let's say square centimeters, for example. And here the water with the salty solution, all the mix is gonna be coming out at a rate that is 4 liters per minute. Okay, so that's the problem. We're putting there like some more salty solution, 8 liters per minute, but the salty solution it's going at a rate of 4 liters per minute. So what we have to get is the concentration. Let's say Y is the concentration of salty solution in the tank. So what we want to achieve is to get the concentration of the salty solution at any time in the tank. So let's see. Let's say A, we need the concentration of salty solution or salt, concentration of salt. When the tank contains 500 liters of salty solution. Okay, and the concentration of salt in the tank after an hour. Okay, so let's check this out. So remember that Y is gonna be the concentration of salt in the tank. Of salt in the tank at a time t. Okay, and this is gonna be measured in kilograms. Okay, so basically by concentration, I mean the number of kilograms. Okay, so the amount of salt, if you want to say better than concentration, maybe amount, it's a better way to say. So we want to see how it changes, and this obviously is gonna depend on the amount of salt that comes in minus the amount of salt that's gonna go out, right? So it depends on the amount of salt that comes in minus the amount of salt that comes out. Okay, so we know that entering it's 8 liters per minute. And we know that each liter contains 1/8 of kilogram of salt. So it means that we have basically 1/8 kilogram of salt per liter. So if we multiply this two, we basically get the liters out, and we get that we have 1 kilogram of salt per minute entering. Okay, so that's the salt that is entering, 1 kilogram per minute. And we know that 8 liters per minute enter the tank But we also know that 4 liters per minute leave the tank. So that means that the balance is positive, and it means that we have actually 4 new liters per minute in the tank added to the initial volume of the tank that it had in water. Okay, so basically it means that the volume of the salty solution is going to be the initial volume of the tank, that it was 400 liters, plus 4 liters times T. So C, that is 4 liters per minute. If we multiply by the time, it's going to give us the liters that are entering in a specific time. So this is going to be the whole quantity of volume of liters in the tank at any point, when we have already balanced out what it comes in and what it comes out. So then if we want to see how many kilograms we have of salt per liters, then we have that the concentration or amount of salt, we said that it was Y. Okay, so Y was measured in kilograms of salt. And here, if we divide by this amount, which is precisely the liters of this salty solution combining homogeneity in a homogeneous mix, is the liters in the tank. What are we gonna get? We're gonna get the number of kilograms of salt per liter. So this is kilograms of salt per liter. Okay. So if we know that from the mix we're getting 4 liters per minute out, then the amount of salt coming out, what will it be? Well, if we multiply something, which is the kilograms of salt per liter, and we multiply it by 4, which is liters per minute, and this, bear in mind, that was kilograms per liter, we're gonna get kilograms per minute that are coming out. So that means that Y divided by 100 plus T is gonna be the kilograms per minute that come out. Kilograms of salt per minute that come out. Hence, well, what do we have then? Well, so then it's easy to check that that's the kilograms of salt per minute that come out. And initially, we had 1/8 kilogram per liter, and coming out at 8 liters per minute. So we basically said that it means that it's entering 1 kilogram per minute. So how is the total amount of salt going to change? Well, the change in time of the total amount of salt, then it's going to be what it enters, which is 1 kilogram per minute, minus what it's leaving the mix. So what is lipidemics, we just calculated it, and this was the equation. So basically, this is going to be the equation that is going to tell us how much or amount of salt in the tank at any point in time t. So now what we have here, it's very simple because we just have a linear equation, and the linear equation, we know how to solve it. Okay, so first we have to solve a part that is gonna be the homogeneous part. Okay, so this would be the homogeneous solution, and the second solution would be by the varying constant method. So let's do it. So how do we do that? Well, we just have to put the homogeneous part, the particular solution that we have to get has to be of the form, the constant of integration is gonna depend on t now, and this is going to be the particular solution, and we have to find this function so we can integrate a whole equation. So now, having in mind that we have the general solution to the differential equation, I leave this for the person that is watching this video to solve it by yourself, because I have already uploaded some videos on linear differential equations, and we have seen the whole process of how one can solve them by the varying constant method. So as we know, one has to sum one particular solution and one homogeneous solution. So once we have the combination of these two, we have the whole G's for general solution. So basically what the problem was asking us, it's what's the concentration of salt in the tank after 1 hour? Well, initially we know the concentration of salt is 0 because we start adding it at time 0. So with this, one should be able to focus the constant of integration, which is obviously only one constant of integration because we depart from our first order differential equation, so we only have one constant. So if you plug time equals 0 here in all the expression, you will just reach that y0 has to be 0. So the expression for our tank, it's simplified to just this expression. And remember something important. The important thing is that we were measuring everything in minutes. So when the problem is asking you the concentration of salt 1 hour after, what are we gonna have? Well, actually, we will have to see the concentration of salt actually in 60 minutes for the 1 hour. So remember that you were gonna put everything in minutes, and this will be basically the concentration in kilograms.